You ever get that feeling, just overwhelmed by information, scrolling endlessly, wishing for a shortcut, like a secret decoder ring for insight?
Oh, definitely. Information overload is real.
Well, that desire to really understand what matters, that's exactly what data science tackles. It's kind of the hidden force shaping things. And today, we're going deep on how it finds meaning in just mountains of raw data.
It's pretty incredible, isn't it? And our mission today is basically to unpack data science, not just what it is,
Right?
but why it's become so critical, how it's changing industries, and some surprising trends happening right now.
And our guide for this deep dive, it's an excellent source. Introduction to Data Science by Kannan Singaravelu. It's actually due out in September 2025. What's really valuable about Singaravelu's take is his background. He's got this unique mix, right? He's not just an academic.
No, not at all.
He's been in finance for over 20 years, managing complex products, advising big clients, and he even created QuantMod.
Yeah, that Python library. Super widely used in quant finance. It helps people visualize and analyze tricky financial data.
Exactly. So when he talks data, he's really speaking from experience, from the trenches.
Precisely. His background connects that theory to, well, intense real-world use. So we'll use his insights to explore the main ideas, some really surprising impacts,
Okay.
and just how powerful data science is, especially in fields like finance, where it's, frankly, revolutionary.
Okay, let's unpack this then. Before we dive right into data science, we kind of need to get the main ingredient, right? The data part. We hear big data all the time. Sounds big, obviously, but what makes it different from just a lot of data? What's the real complexity?
That's a really good question.
Yeah.
Because Singaravelu makes it clear big data is a relative term.
Relative.
Yeah. It's not some fixed amount.
Yeah.
It's data that's big compared to what we used to be able to handle,
Yeah.
with the older tools and methods.
Oh, okay. So stuff that was impossible 10 years ago is maybe routine now.
Exactly. It's about the challenge it presents to our current capabilities.
And there's that framework people talk about, the 4 Vs. Helps break down that challenge.
Yep. The 4 Vs, they really help capture the different facets of big data.
Can you walk us through them, but maybe focus on, what's the trickiest part of each V for businesses today?
Sure. So first, volume, obvious one, right? The sheer amount of data, petabytes, zettabytes.
This massive scale.
Right. But the challenge isn't just storage anymore. It's finding the actual insights, the needles, in that enormous digital haystack.
Okay. Makes sense. What's next?
Velocity. This is the speed. Data's flowing in constantly, often in real time, from everywhere.
Like a fire hose.
Exactly.
Yeah.
And the headache here, it's processing and reacting fast enough. If the insight comes too late, the opportunity might be gone.
So collecting isn't enough. You need instant reaction.
Precisely. Then comes variety. Data isn't just neat rows and columns anymore. It's structured numbers, sure, but also unstructured text, images, audio, video, all sorts. The challenge is getting these different types to, well, talk to each other, harmonizing them for analysis.
Making sense of the mess.
Pretty much. And finally, veracity. This one's crucial and honestly, often overlooked.
Veracity, so truthfulness, quality.
Exactly. Trustworthiness. A lot of this data just happens. It's organic, generated out in the wild, not in some controlled lab.
So it might not be clean or accurate.
It might not be. And the biggest challenge with veracity is dealing with that uncertainty. How much can you trust the insights you get from data that might be noisy or biased, especially for big decisions? It really forces a rethink about truth in data.
Wow, yeah. That veracity point is deep. It's not just garbage in, garbage out. It's about the impact of potentially flawed data. Okay, so we have this massive, fast, messy, maybe untrustworthy big data. How does data science actually step in and, make sense of it all?
Think of data science as the toolkit, or maybe the discipline, for dealing with that chaos. It's interdisciplinary. It uses scientific methods, fancy algorithms, systems, all aimed at mining value.
Grinding.
Yeah, extracting knowledge, finding those hidden patterns in both structured and unstructured data that lead to actionable insights.
It sounds like it needs a mix of skills then, not just one thing.
Oh, absolutely. You can't just be a coder or just a stats whiz. Our source breaks it down into 4 core parts.
Okay.
First, statistics and mathematics. That's fundamental. Probability, modeling, understanding the patterns. It's the theoretical base.
Right, the foundation.
Second, computer science. You need the programming chops, database skills, algorithms, the tools to actually handle the data, especially at scale.
And then you've got to know what the numbers actually mean, right, in the real world.
Exactly. Which brings us to domain expertise. This is so important. You could find a pattern, statistically speaking, but if you don't understand the business or the field, say,
Mm,
finance, you could completely misinterpret it.
yeah, context is everything.
Totally. And the fourth piece, maybe the most critical, communication.
Ah, talking to humans.
Haha, basically. Being able to translate complex technical stuff into clear, compelling insights that leaders can actually understand and, crucially, act on.
Yeah.
DJ Patil, the former U.S. chief data scientist,
Yeah.
he nailed it. Data science is the extraction of actionable knowledge. That word, actionable, that's the key. It has to lead somewhere.
Actionable knowledge, that's where it gets really practical. So why is this field so vital now? Why should someone listening care about data science beyond the tech? What's the real impact on, say, your daily life?
Well, the impact is huge because it fundamentally changes how decisions get made. Instead of just gut feelings or intuition.
Which can be wrong.
Often, organizations can use evidence, hard data. This gives them a serious competitive advantage. Companies using data science well tend to spot opportunities and fix problems faster than others.
So smarter, quicker decisions.
Definitely. But it's also a massive innovation catalyst. Think about new products, new services, personalized recommendations on streaming,
Yeah.
or self-driving features in cars. That's all data science enabling new things. It
Yeah.
also massively improves the customer experience. Companies understand you better, personalize things, offer better service.
Okay.
And critically, it helps with risk mitigation, identifying potential issues, fraud, market shifts,
Hmm.
before they become big problems.
It's interesting how fast AI is becoming central to this. I saw a stat Singaravelu quotes from an Anaconda report, January 2025. Something like 87% of data scientists are spending as much or more time on AI techniques compared to the year before.
Right, 87%. That's not slow growth. That's like warp speed adoption.
Yeah.
It really shows data science isn't standing still. It's constantly absorbing these cutting-edge AI methods to get even better results. And businesses are seeing it.
How so?
Better decisions, real gains in operational efficiency, much stronger predictive power. These aren't just buzzwords anymore. They're measurable outcomes.
Those benefits sound great, but let's get specific. How does this actually play out for you, the listener? The source mentions healthcare, retail, but let's zoom in on finance. Given Singaravelu's background, what's happening there?
Finance is a fantastic example. It's being totally reshaped. Take fraud detection.
Okay.
Machine learning models scan transactions constantly, spotting weird patterns way faster than any human could. Our source mentions a 45% reduction in false positives.
Wow, so fewer legit transactions get blocked. That's huge for customers.
Huge. Less frustration, more trust. Then there's risk management.
Right.
Predictive models analyze credit risk, market swings, operational stuff,
Yeah.
helping banks make smarter choices. We're talking about a 30% improved risk assessment, according to the source. That affects everything from loans to investments.
Stability, basically.
Exactly. And then there's algorithmic trading. This is mind-blowing.
That's trading stocks.
Pretty much.
Yeah.
AI algorithms crunch market data and execute trades at insane speeds. Get this. The source says 70% of trading volume is algorithmic now.
70%, that's most of it.
The vast majority.
Yeah.
Humans just can't compete at that scale and speed. It's fundamentally changed how markets work.
So data science is basically running the stock market now.
In large part, yes. But beyond that, it's also driving personalized banking services,
Yeah?
making customer interactions smoother, improving how credit decisions are made using ML. It's everywhere.
It really drives home the real-world impact for you getting a loan, investing, even just swiping your card. Okay, but there are so many data job titles now. Data scientist, data engineer.
Yeah.
It gets confusing. How do they all fit together?
Yeah, it can be a bit of alphabet soup. The source clarifies it well by looking at their main focus and what they typically deliver.
Okay.
Data science, like we've been saying, focuses on extracting those actionable insights. They deliver predictive models, cool visualizations, the story in the data.
The detectives and storytellers. Got it.
Right. Then you have data engineering. Think of them as the architects and plumbers.
Plumber.
Yeah, they build the infrastructure. Their main job is creating solid data pipelines and databases, making sure the data is clean, reliable, and accessible for everyone else.
Okay, essential groundwork.
Crucial. Then ML engineering. They take the models built by data scientists and actually put them into production, make them work in the real world reliably at scale. They deliver the deployed models and the systems to monitor them.
So making the science operational.
Exactly. And finally, business intelligence, or BI. They often focus more on the what happened and what's happening now. They create dashboards, track KPIs, provide reports for immediate business decisions.
So different roles, but they all sound like they need to work together pretty closely.
Absolutely. It's a team sport. You rarely find one person who's an expert in all those areas. They collaborate to build the whole solution.
Makes sense. Now, to do all this amazing stuff, you need the right tools. And looking ahead, where's this field going? What are the big trends we should watch out for?
Tool-wise, the basics are still strong. Python, R, SQL are key languages. Python's hugely popular.
Yeah, seems like everyone uses Python.
It's very versatile.
Yeah.
And then libraries like Pandas, NumPy for manipulating data, scikit-learn for standard ML,
Yeah.
and then TensorFlow and PyTorch for the heavy-duty deep learning, the AI stuff.
Hmm.
These are all still dominant in 2025.
Okay, solid toolkit. But what's next? What's the really exciting, maybe even slightly scary future stuff?
Well, one massive trend is agentic AI systems.
Agentic, meaning like secret agents.
Kind of.
Yeah.
Think autonomous AI agents that could do complex tasks, make decisions, even string actions together, and learn without constant human oversight.
Whoa.
Yeah, AI that could potentially manage a whole project, adapting as it goes. It's going to completely change automation. Another huge area is unstructured data analysis.
Getting insights from text, images, video.
Exactly. Moving beyond the numbers. Using advanced NLP, computer vision. Imagine understanding the sentiment in millions of customer service calls automatically, or analyzing video feeds for patterns. The potential is enormous.
So understanding the whole messy digital world, not just the neat parts, and having AI that can act on its own.
Precisely.
Hmm.
But alongside that power comes a really important focus: responsible AI and ethics.
Ah, the should we question.
Exactly. As AI gets more powerful, more autonomous, we have to ensure it's fair, transparent, accountable. It's not just talk. It's becoming a practical need for trust and adoption. New rules, new governance frameworks are popping up.
So guardrails for the agents.
You could say that. We're also seeing more focus on actually measuring the ROI of AI and new leadership roles emerging, like chief AI officer, to steer the ship.
It's a fast-moving space. Okay, so for someone listening, maybe feeling inspired, thinking, wow, I want to get into this, how do you even start? It seems daunting. Is there a roadmap?
There is. The source actually lays out a pretty clear 5-step path. First, build a foundation.
The basics.
Right. Learn programming basics. Python or R are good bets. Get comfortable with core statistics and math concepts, probability, linear algebra, data structures.
Okay, step 1, fundamentals.
Step 2, master essential tools. Get really good with data manipulation libraries like Pandas, NumPy. Learn visualization tools like Matplotlib or Seaborn. And definitely learn SQL for databases.
It's a practical toolkit.
Yep. Step 3, learn machine learning. Study the main algorithms, understand where they're used, and get hands-on practice with libraries like scikit-learn. Start with supervised learning, maybe.
Learning the actual science part.
Exactly. Then step 4, and this is crucial, build a portfolio.
Show your work.
Precisely. Do personal projects with real data. Document everything, your process, your code, your findings. Put it on GitHub. This is how you demonstrate your skills.
Your proof.
Your proof. And finally, step 5, specialize in network. Pick an area you're interested in, finance, healthcare, whatever, and go deeper. And connect with people. Join online communities, go to meetups or conferences.
Yeah.
Networking is huge for learning and finding opportunities.
That seems like a solid plan. It really highlights that doing projects and connecting with others is just as vital as knowing the theory.
Absolutely. It's about applying it and being part of the conversation.
So we've really covered a lot today. We journeyed through this whole dynamic world of data science, from the 4 V's of big data to seeing its real measurable impact in areas like finance, glimpsing these future trends.
Agentic AI.
Right, and even getting a roadmap for how you could start your own journey.
And what's so fascinating, I think, is that data science isn't just technical. It's fundamentally about making sense of complexity,
Yeah.
turning this flood of information into real understanding, and hopefully into actions that make a difference. It's quietly reshaping so much around us.
So the next time you see one of those super relevant ads or get a fraud alert that's actually correct or hear about some complex market forecasts, take a second. Consider that invisible symphony of data science working behind the scenes. How might knowing this change a decision you make? Or just how you look at the information hitting you every day?
Yeah, and that makes you wonder, doesn't it? What other parts of your life are being optimized or influenced by data in ways you haven't even noticed? And thinking about that, what unexpected opportunities might that awareness unlock for you? Something to think about.